In this tutorial, you will learn how to model a pair of mating bevel gears in Blender. The tutorial will cover the modeling of a pair of gears with curved teeth, involute tooth profiles, and shafts, intersecting, at a non-right angle. Let's take a quick look at the regular gears, known as spur gears, first. Conceptually, a pair of mating gears can be represented by two touching cylinders. The bases of the cylinders are called the reference circles. A spur gear system can be fully defined by as few as 3 parameters, the number of teeth in each gear, and a number, called module, shared by both gears. The module determines the diameters of the reference circles, known as the reference diameters, calculated as the product of the module and number of teeth. The sides of the gear teeth are usually curved, and the curve, called the involute, can be described with a pair of simple parametric equations. Let's go back to bevel gears. Conceptually, a pair of mating bevel gears can be represented by two touching cones, called reference cones. A bevel gear system can be fully defined by the number of teeth in each gear, the module, shared by both gears, the angle between the shafts, and the length of the contact line of the reference cones, called face width. We have developed a free online calculator which enables you to enter the bevel gear parameters just mentioned, and obtain all other parameters necessary to model a bevel gear pair. This calculator can be found at www.vinted.com/bevel.html. The modeling procedure of a bevel gear wheel is as follows. First, model the outline of a single tooth. Rotate the tooth around a point where the reference circle intersects its centerline. Position the pivot point at the apex of the reference cone. Duplicate the tooth and scale it down relative to the pivot point. The rotation angle, position of the apex, and scaling factor, used in these transformations, are provided by the online calculator, as will be demonstrated shortly. Bridge the two pieces to form the sides of the tooth. Duplicate and rotate the tooth around the cone axis until the entire wheel is completed. Optionally, make the teeth curved. Let's start modeling. Delete the default cube by pressing X. Press 7 on the numeric keypad to switch to the top view. Press 5 to switch to the orthogonal view mode. Select 3D cursor as the pivot point. Go to User Preferences, and on the Add-ons tab, make sure Add Mesh, Extra Objects is checked. Everywhere in this tutorial, the smaller of the two gear wheels is referred to as pinion, and the larger one simply as gear. Go to the bevel gear calculator at www.vinted.com/bevel.html. Enter 1 for module, 18 for the number of teeth on the pinion, and 36 for the number of teeth on the gear. To make things more interesting, we will design a bevel gear system with the shafts intersecting at a non-right angle. Enter 100 for the shaft angle. Any reasonable number can be chosen for the face width. We will use 6. Now press the Calculate button. The equations for the tooth profiles for both the pinion and gear are now calculated, as well as many other useful parameters which we will be using momentarily. Let's model the pinion first. Back in Blender, click Shift-A, Mesh, Math Function, XYZ Math Surface. Copy and paste the X and Y equations from the gear calculator to the corresponding boxes of the XYZ math surface properties. Enter 0 for Z function. Umin should remain 0, and Umax should be copied from the Umax box of the calculator. Enter 10 for U-step and uncheck the UWrap checkbox. Since the V parameter is not used, enter 0 for Vmin and Vmax, and 1 for V-step. Press Tab to enter the edit mode and click on the Remove Doubles button on the Mesh Tools panel. We have just modeled the side of a pinion tooth profile. Press Shift-D to duplicate, then S for scale, then Y, then -1, then Enter, to create a mirror reflection. Rotate it around the Z-axis by the angle provided by the calculator's tooth thickness at base box. We recommend using copying and pasting throughout the tutorial. In the calculator, press Ctrl-C to copy the angle value to the clipboard. In Blender, press R to rotate, then Z, then Ctrl-V to paste the angle value, then Enter. Select the two far right vertices and press F to form the tooth tip. We now need to have the tooth straddle the x-axis. Bring up the system calculator and divide the angle value just used, by 2. Go to the Edit menu and select Copy to copy this value to the clipboard. In Blender, press A twice to select everything. Then press R to rotate, then Z, then the minus sign, then Ctrl-V to paste the angle value, then Enter. Create 2 more teeth to flank this tooth. Press Shift-D to duplicate, then R to rotate, then Z, then 20, then Enter. 20 is the angular distance between the adjacent teeth of the pinion, since it has 18 teeth, and 360 divided by 18 is 20. Now create a third tooth on the other end of the original tooth. Press Shift-D to duplicate, then R to rotate, then Z, then -40. Select these 2 vertices, then press Shift-S and select Cursor to selected. Unselect the top vertex. Press the Spin button on the Mesh Tools panel. Keep 90 degrees for the angle, and enter rate for the number of steps. Repeat the same procedure for the bottom half of the tooth. When using the Spin tool, change 90 to -90. Select the vertices of the top and bottom teeth and delete them. Press Shift-C to return the 3D cursor back to the origin. Select everything and press F to form a face covering the entire tooth. Switch to the Edge Select mode and select the newly created edge. Extrude it to the left along the x-axis by pressing E, then X, then -1. This rectangle forms the base of the tooth. Its size is not important and we chose one for purely aesthetic reasons. Press Tab to exit the edit mode. The tooth needs to be rotated relative to the reference circle. Press N to bring up the Numbers panel. Enter the reference radius value as the x-coordinate of the 3D cursor. According to the calculator, this number is 9. In the calculator, copy the reference cone angle value to the clipboard. In Blender, press R to rotate, then Y, then minus, then Ctrl-V to paste the angle, then Enter. Press Shift-C to return the 3D cursor back to the origin. Press Tab to enter the edit mode and select everything. Press Shift-D to duplicate, then R to rotate, then Z, then 20, then Enter. Now press Shift-D to duplicate, then R to rotate, then Z, then -40. Press Z to switch to the X-ray mode. Merge these pairs of vertices by pressing Alt-M and selecting at center. Press Z to exit the X-ray mode. Keep the vertices of the original tooth and delete all other vertices. Press Tab to exit the edit mode. Now position the 3D cursor at the apex of the reference cone. Copy the cone base to apex height from the calculator to the Z coordinate box of the 3D cursor. Press the Set Origin button and select Origin to 3D cursor. Enter the Edit mode and press A to select everything. In the calculator, copy the top-bottom scaling factor to the clipboard. In Blender, press Shift-D to duplicate, then S to scale, then Ctrl-V to use the number in the clipboard as the scaling factor, then enter. Press A to select everything. Press Shift-D to duplicate, then enter. Press W and select Bridge Edge Loops. Press A, twice, to select everything and click on the Remove Doubles button. Our tooth is essentially ready. Before duplicating it, we need to delete these 3 faces. Select everything, press Shift-D to duplicate, then R to rotate, then Z, then 20. Select everything, press Shift-D to duplicate, then R, then Z, then 40. Repeat until the entire wheel is complete. Select everything and click on the Remove Doubles button. Turn this surface into a manifold object by creating a circle of vertices at the top, extruding it downwards and using the bridge edge loops to complete the design. Select everything and press Ctrl-N to fix the normals. All that is left to do is curve the teeth. Press Ctrl-R to use the Loop Cut tool. Create 5 loop cuts by rotating the mouse wheel. The number of cuts is arbitrary, but it is important to remember this number, as the exact same number of cuts will have to be made on the second gear wheel as well. We will be rotating the newly created loops by 2, 4, 6, 8, 10, and 12 degrees, starting from the top loop. Press Shift-C to make sure the 3D cursor is in its default position. While holding down the Alt key, right-click on the first loop from the top and select R to rotate, then Z, then 2, then enter. Press A to deselect everything. Repeat this step for the second, third, fourth and fifth loops. Rotate them by 4, 6, 8, and 10 degrees, respectively. To select the entire bottom part of the model, switch to the Face Select mode and select these 2 faces. Then press Shift-G and select Area. Now perform the last rotation by 12 degrees by pressing R, then Z, then 12, then enter. Our pinion is ready. Now let's model the gear. To avoid clutter, we will model it on the second layer. Press Shift-A, and select Mesh, Math Function, XYZ Math Surface. This time, copy the equations and Umax parameter from the second group of boxes of the calculator. Press Tab to enter the Edit mode and press Remove Doubles button. Duplicate the curve relative to the x-axis by pressing Shift-D, then S, then Y, then -1, then enter. In the calculator, copy the tooth thickness at base value from the second column of the table to the clipboard. In Blender, press R to rotate, then Z, then Ctrl-V to use the number in the clipboard as the rotation angle. Rotate in the opposite direction by half the angle used in the previous step to have the tooth straddle the x-axis. Form the tip of the tooth also. Add 2 flanking teeth by duplicating this tooth and rotating it by 10 degrees, and then duplicating it again and rotating it by -20 degrees. Using the spin tool, add two connecting curves. Delete the flanking teeth. Select everything and press F to create a face covering the entire tooth. Extrude the newly created edge to the left by 1 to form a base for the tooth. Press Tab to exit the edit mode. Enter the reference radius in the X box of the 3D cursor and make sure the Y and Z values are both 0. The reference radius for the gear is 18. Rotate the tooth around the Y-axis by the reference cone angle provided by the calculator. Do not forget the minus sign. Press Tab to enter the edit mode. Create two flanking teeth again and merge the neighboring pairs of vertices on both sides of the tooth. Then delete the flanking teeth. Press Tab to exit the edit mode. Position the 3D cursor on the apex of the reference cone. Enter the cone base to apex height value, provided by the calculator, in the Z coordinate of the 3D cursor and make sure the X and Y coordinates are both 0. Click on the Set Origin button and select Origin to 3D cursor. Enter the edit mode by pressing Tab and select everything. Duplicate the tooth and scale it down by the top/bottom scaling factor provided by the calculator. Select everything, duplicate by pressing Shift-D, click W and select Bridge Edge Loops. Select everything again, and press the Remove Doubles button. Remove these three faces. Duplicate and rotate the tooth by 10 degrees, then duplicate and rotate by 20 degrees, and so on, until the entire wheel is modeled. Select everything and click on the Remove Doubles button. Turn the gear surface into a manifold object. Select everything and click Ctrl-N, to fix the normals. Create 5 loop cuts. Since our gear ratio is 0.5, the rotation angles for each loop should be half of what the angles were when the pinion's teeth were being curved, and the rotations must be made in the opposite directions. Rotate the loops by -1, -2, -3, -4, -5 and -6 degrees. Our gear is done. Move the gear to layer 1 by pressing M, and selecting layer 1. Join the origins of both wheels. Select the gear. Press Shift-S and select Cursor to Selected. Then select the pinion, press Shift-S and select Selected to Cursor. Now rotate the pinion around the X-axis by 100 degrees by pressing R, then X, then 100, then Enter. Our design is complete. The rest of the tutorial will describe testing the two wheels for compatibility using Blender's rigid body physics engine. Let's give our two wheels proper names, pinion and gear. Make sure the 3D cursor is still on the origin of either wheel. Add a cylinder and rotate it around the x-axis by 100 degrees. Call it axis 1. Add an empty of the type arrows. Rotate it around the x-axis by 100 degrees. Call it hinge 1. Add another empty of the type arrows. Rotate it around the z-axis by 90 degrees. Then rotate it around the x-axis by 10 degrees so that the empty's x-axis coincides with the pinion's axis. Call this empty motor 1. Create another cylinder and move it up. Call it axis 2. Create another empty of the type arrows and move it up. Call it hinge 2. Select the pinion. In the Physics tab, click on the Rigid Body button. Select Mesh for Shape and 0 for Margin. Select the cylinder called Axis 1. Click on the Rigid Body button. Select Passive for Type. Select the empty called Hinge 1. Click on the Rigid Body Constraint button. Select Hinge for Type. Select the pinion as Object 1 and the cylinder called Axis 1 as Object 2. Select the empty called Motor 1. Click on the Rigid Body Constraint button. Select Motor for Type. Select the pinion as Object 1 and the cylinder called Axis 1 as Object 2. Enable the Angular Motor. Select the gear. Click on the Rigid Body button. Select Mesh for Type and 0 for Margin. Select the cylinder called Axis 2. Click on the Rigid Body button. Select Passive for Type. Select the empty called Hinge 2. Click on the Rigid Body Constraint button. Select Hinge for Type. Select the gear as Object 1 and the cylinder called Axis 2 as Object 2. Our setup is ready. Click on the Play button to start the simulation. Our Bevel gear drive is working. And this concludes our tutorial.